Hi guys, welcome back to final exam. This is review C. I think we left off yesterday at 22. So we're going to start this video with number 23. It says find the exact value of cosecant negative 5 pi over 4. I had some people ask them, but wait, that is not in the range of it. But keep in mind, if you're asking for sine or cosine or even cosecant or secant, and it doesn't have the inverse, you're not restricted by anything, unless it's got asymptotes. But for cosecant of negative 5 pi over 4, we're not restricted in our domain. The only thing you're restricted by, if it was cosecant inverse, then we would be restricted. All right, so cosecant we know is 1 over sine. So first I want to find sine of negative 5 pi over 4. So remember, negative 5 pi over 4, we're going to start at 0, we're going to go backwards instead of forwards. So we're going to go backwards and we're going to go 5 pi over 4. So remember, pi over 4 cuts each quadrant in half. So here's 1 pi, 2 pi, this would be negative 3 pi, negative 4 pi. This guy right here is negative 5 pi over 4. It's coterminal with positive 3 pi over 4, which is on the unit circle, and we know that value would be negative square root of 2 over 2, square root of 2 over 2. So the sine of this point here, of this angle, is the y value. So this is going to be 1 over the square root of 2 over 2. So we got 1 over 1 times the reciprocal of this guy, which is 2 over the square root of 2. That gives me 2 over the square root of 2, but of course we can't leave it like that. We're going to rationalize the denominator. And I get 2 square root of 2 over 2. Finally, the 2's cancel out, and so that's just the square root of 2. And that's C. All right, 24. Suppose that sine theta is equal to negative 2/5, and it is in quadrant 4. So you're in quadrant 4 somewhere. I'm just drawing a random angle. We know sine, which is opposite over adjacent, is negative 2 over 5. And then what we're going to find secant. Well, secant is 1 over cosine theta, which means I need to know my adjacent over hypotenuse. To find this value here, we're going to use Pythagorean theorem. So x squared plus negative 2 squared is equal to 5 squared. X squared plus 4 is equal to 25. X squared is equal to 21. X is equal to the square root of 21. And we know it's positive because we're in the fourth quadrant and X is positive. So cosine theta would be square root of 21 over 5. But because it's secant theta, we want the reciprocal of this guy, which would be 5 over the square root of 21. Which this time, for whatever reason, they did not rationalize the denominator. If I'm on my A game, I will have the denominator rationalized on your final. All right, 27, the range of the sine function. Okay, typical sine function starts here, goes here, and we're going up 1, down 1. But for this new function here, we're shifting it down 4. So it's talking about range. We don't care about what's happening to the x's. We just care about what's happening to our y's. So we're shifting down 4. That's my new midline. And then we're stretching by 5. So from my midline, we're going to go up 1, 2, 3, 4, 5, which would be here at 0. Oh, sorry, just kidding. I drew it too low. This is not working out. So we started here at 0. We're shifting down 1, 2, 3, 4. This is my new midline, sorry. And then we're also stretching by 5, which means we're going to go up 5 and then down 1, 2, 3, 4, 5. So from this negative 4 minus 5, that would be negative 9. So my range now, we would look something like this. My range goes from negative 9 up to positive 1, including both of those endpoints. And so that is D. I don't think you can see this very well. I think when I copied this guy over, it's supposed to be 22 pi over 3. And so you guys are getting confused by making it negative 22 pi over 3, but I think it just didn't copy that fraction bar all the way. So let's do 22 pi over 3. That means we're going to take 1 pi, which is half of my circle, and divide it into 3s. And I'll do the same thing. These are 60-degree angles is what we really have. Should they look more like that, but you get the idea. So here's 0 pi over 3, 1 pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3, 5 pi over 3, 6 pi over 3, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22 corresponds to this angle. And so then the one that is coterminal with on our unit circle would be pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3. So just kidding. That one's not on, I think the answer choice was none of the above. I'm not sure what they have down there. I thought I had figured it out. I think it's a block problem. Just know that you're going to have one on the final that asks you to find the angle that's coterminal with it. And what you want to do is figure out where does your angle lie on the unit circle, and then figure out what is the corresponding unit circle angle that lies on there as well. If you were trying to find something that's, say, coterminal with 22 pi over 3, which is what we're doing, I would subtract off 2 pi and see if that angle is on the unit circle. And then you can subtract off 2 pi again, see if that angle, and keep subtracting off 2 pi until you get one that's on the unit circle. Likewise, if you had, say, something that was 720 degrees, and I want to find the one that's coterminal with this on the U-turn, on the unit circle, I would subtract off not 2 pi, but 180 degrees. What, 180 degrees, Miss Harris? 320 degrees. Not kidding. It's early. I need my coffee. 360 degrees. The number of degrees in a circle. I keep subtracting off 360 degrees until I found an angle that was on the unit circle. They don't have to be on the unit circle, so they could say find something that's coterminal with, say, 36 degrees. And so to find something that's coterminal with 36 degrees, you just add 360 to it. And then 393 is coterminal with it. So it doesn't have to be on the unit circle, but this one should be on the unit circle if it was a good problem. All right, number 29, find the exact value of cotangent inverse of 1. So I want to know, where is my cotangent 1? So where is x over y 1 on the unit circle? And for x over y to be 1, I need both x and y to be the same thing. And that only occurs when we at one place on the unit circle, and that's where we got the square root of 2 over 2 and the square root of 2 over 2. So if you look on your unit circle, where do we have the square root of 2 over 2? Square root of 2 over 2. That would be at pi over 4. Or if these guys were both negative, that would also give us a positive 1, and that would be at that would be at 5 pi over 4. All right, so those are our two options, and we want to know the exact value for cotangent. So keep in mind your cotangent inverse, though, has a range of 0 to pi, so it can't be this guy down here. Remember, it's going to be pi over 4. So that goes based off our range. We didn't really talk about cotangent inverse. You'll see it's a problem similar to this, but it's going to be sine, cosine, or tangent. So tan inverse would be totally acceptable. This one's stretching you a bit far, especially if you're an academic. Don't worry, I won't put a cotangent inverse on there, but I might ask you, where is tan inverse 1? And that would be at pi over 4 as well. All right, for number 30, a 79-foot guy wire is attached to the top of the 23-foot antenna to a point on the ground. So we know the guy wire is 79 feet, and The top of the antenna is 23 feet. What angle does the guy want to make with the ground? So we're looking for this angle here. Since I have opposite and hypotenuse, I'm going to use sine theta is 23 feet divided by 79 feet. Now I want to get that theta out of there, so I'm going to take the sine inverse. Because the sine inverse of sine theta spits out just theta. And then on the other side, I got sine inverse of 23 over 79. Be careful if you choose to use a yellow calculator during the test, that you make sure that you figure out your degrees and radians before. These answers are written in degrees, so you're going to want to put your document into degrees, or use the degree symbol before you work the problem. Which is what I'm doing right now. I can't remember what the answer is. I think it's 16.93, but. All right, so I've got sine inverse of 23 divided by 79 in degree mode gives me 16.93. All right, so the last video will cover, oh, there's just one more question. Excellent. All right, convert 210 degrees to radians, express your answer as a multiple of pi. So 210 degrees, I want to go to radians. I know there's 180 degrees for every pi. So halfway around the circle is 180 degrees, halfway around the circle is pi radians. Now our degrees cancel out, and we're in radians. 30 goes into 210 7 times, and into 186 times. So this would give me 7 pi over 6, which, if there was a fraction bar, would be number 31. All right, that's it for review C, and I will start the review B video is coming up next.